Hello everyone, welcome to your next section. Today we are going to actually do a couple of different types of natural language processing. We're first going to boot up like a Shakespearean play and do some basic analysis with it. We're going to show you how to use sentiment analysis very basically, as well as a couple other things. So you're going to start to understand the basics of natural language processing code beyond just playing with a couple of initialization scripts and like making a couple of functions work. We're actually going to upload a corpus that we're going to do a couple of different analytic tricks on, and then show you some indexing and all different types of good stuff with natural language processing. So first, we're going to learn how to process text for a natural language processing analysis. We're going to get the text down to a point where we can then start to run a statistical test on it, which we'll run in our next section. We're going to learn how to upload and practice with Natural Language Toolkit Corpi. We're going to deal with a Shakespeare play today, Macbeth, one of my favorites. So you're going to learn how to do take large bodies of text and start to analyze them. And we're going to create one NLP function, which is a very simple basic process of natural language processing called text denoising, which I'll explain to you in a bit. Last thing we're going to do is we're going to set up something called an n-gram analysis. We're going to create n-grams. So what are our definitions? First, what is text denoising? Basically, text denoising is removing words that are kind of super repetitive or exist in so much of English language that they render themselves basically useless for analytics. Words like the, is, they occur so much in language that they create noise when we try to analyze things, because all of those words are just so common that they end up making the things that are less common a little not come to the surface as much. So a common thing with natural language processing is to do something called denoising, which is removing very common or unnecessary words. The next thing we're going to learn is how to do n-gram analysis, which is essentially taking pairs of or sets of words one at a time and seeing how often those phrases come about. Think of it like if I take the first two words of every sentence, like a sentence like, I love to learn data science. If this was a 2-gram or a bigram analysis, each pairing of words would be like, I love is one, love data is the next, data science is the next bigram, okay? So each of those three sets of pairs of words would be a 2-gram analysis, and we're going to look at that a little bit more. Okay guys, so with that in mind, we're going to hop into our syntax section, and I'm going to show you how all this code is going to work out for us and how it plays out. Okay, so first things first, like always, we are importing a set of packages here. The first thing we're uploading or loading into memory is some of the corpus that we downloaded from our previous section. We're getting the Gutenberg corpus, which contains our William Shakespeare plays. We are then importing the n-grams function, so we can play with n-grams a little bit, at least create n-grams, so we could do some NLP perhaps later on. And then we also are downloading the sentiment analysis package, so we can pass in some text and have it give us the sentiment for it, okay? So that's basically what we have here. We have two functions and a corpus that we're gonna download some text from. The first thing you see here is something we haven't really looked at in a little bit, which is a function. Remember how our function syntax works. We go define, we give the name of the function, and then we tell it any parameters that it needs to have passed through it. So this says, in order to remove noise, it needs some text if we were to pass this function in. We then create a list of noise words here. Is, this, and this ... is representing what other words that we want to include to denoise. This is including ellipses, but the is another word that we might want to include in this as well. It then takes our input text and splits it into a list by using that split command I mentioned before. It looks like the default for split is 4 spaces, so they didn't include the space like I did before. Here is something really interesting that you haven't been exposed to yet. This is a one-line for loop with an if conditional statement. This is called a list comprehension. free. I'll just do that there. And so what this is saying is you have your for loop here for word and words. You then put your conditional statement to the right, which is, this needs to be true. And then you put the parameter for the word, like what is going to go into the list on the left-hand side of the for loop. So in this case, if a word is in the noise list, it's not going to run this here. You can look at the syntax for list comprehensions to see how else works in these, but these are very, very useful as you start to master for loops. You're going to start to do more of these list comprehensions because they're very easy to do. They're one-liners and they're nice and parsimonious. So this is really just like 3 lines where we have for all the way here, and then we have our conditional statement, which would have continue, and then either an else statement. So this would be like 4 lines that we've just condensed into 1, and we've created that list called noise-free words, words without noise. Lastly, we convert this list back into a string by using the .join function. What .join does is it will put all of the elements of a list together, separated by whatever characters you place in here. Okay, so this is saying put all the characters back together in this list and separate them by a space. And lastly, we then return the text without the noise words in it. Okay, and so we would end up having to save some variable here if we wanted that to happen. Okay, so that is what that function is doing, guys. What's going on here is that we're loading in our corpus. So first we say, let's load up the different Gutenberg file names. And then now that that's loaded up, this object has been created. And so we then say, hey, Gutenberg object, I want the sentences for Shakespeare's Macbeth. Okay? And we're saving that in Macbeth sentences as a variable. The next thing we do is I'm showing you how to just test the sentiment analyzer. So we'll give the sentiment analyzer some text, and you'll see what the output of that sentiment analysis is. So we're going to NLTK, sentiment analyzer, and then here's the function. There's a few other functions within sentiment analyzer, as you can tell. So we'll play with that. It basically returns to a dictionary with 4 types of sentiments, each key being like positive, negative, compound, or neutral. And we can look at what each of those values means once we do that. These prints here are just me showing you how the Macbeth sentences are working, what we can do with them, and what's going on here. So we'll play with this more in our Jupyter notebook. And then lastly, we have our n-grams here. So basically what we get with this is one sentence in Macbeth. And if we wanted to turn that sentence into n-grams, we pass to it the string that we want it to separate, and we tell it how many grams that we want it to be, bigrams in this case. So this will then pack all of our words into pairs of words windowed across the entire sentence. And then lastly, what we're showing you here is each of the grams, so just printing them. And I guess in a bit of a reversal of showing you the function, we then run the function down here, where we get the raw text for Shakespeare's Macbeth, and we do our denoising here for Macbeth. We will probably use this denoised text in our next section when we do an actual statistical analysis tool called TF-IDF. All right, guys, here we are in our code. So as I was talking about before, remember we need to initialize some packages. We're first going to initialize the Gutenberg package, which is carrying all of our language corpus. Our Macbeth from Shakespeare is in there. We learned how to load all this and install it in our last section when we did nltk.download in parentheses to boot up the window that will install all that stuff for us. We then install the n-grams function, or we load up the n-grams function from nltk, and then this is slightly different than what you saw in your syntax before. I'm just importing a slightly different sentiment analyzer because I'm finding that this one's just a little bit easier to manage with you guys. So it's not any harder, it's actually easier in the end, so please don't be too disrupted by that. It's just a slightly different package, okay? So we have our function here. Remember how the syntax of our functions go. We define our function, we call def, and then we give our function a name, and we tell it any required parameters or optional parameters using args or keyword args, or no parameters at all, it doesn't matter. You'll notice that we added a few words here. So the point of this is you can add a larger noise list and get more noisy information out. we talked about this amazing list comprehension, which is 3 words compacted into one. We could just, if we didn't have any conditional, we just want to do like word.lower or something like that, we could do that. But for now, we have a conditional where we want to get rid of the stuff in the noise list. We split our text into a list so that we can iterate across it, and then we convert it back into a sentence, all right? And then we pass this information back up so that the object has now been, the string has now been denoised. So we should save that variable later on as we run this function. So the next thing we're doing is we're calling on all of the Gutenberg files that are available and saying that we specifically want Shakespeare's Macbeth, okay? We're saying that we want the sentences for Shakespeare's Macbeth, and I'll show you what that looks like right now. Let's do that. Print Macbeth sentences, you know, let's go 0 to 9 and see what prints. So there you have it. You have, like, as you can see here, we have a list of lists. First thing we have is The Tragedy of Macbeth by William Shakespeare in 1603. And then we have, you know, here's the first line. When shall we three meet again? Okay? In thunder, lightning, or in rain. That is definitely the first lines of Macbeth. I can guarantee you guys. So with that, we now have our sentences. Now what happens if we just pull up the raw? We go Gutenberg.raw and we don't want all of this delineated by sentences. We might want to like figure out our own way of doing that. So let's first see what kind of object raw is. I told you ahead of time that Macbeth sentences was a list, but it's not abundantly clear to me what this could possibly be. Let's also just close that up first. What we see is it's a string, okay? Well, that's useful for us. Oops. Sorry, guys. It's a string. Okay, so that means if we index this, print Macbeth from 0, like for the first 200 characters, what do we get? We get what looks like a lot easier to read, and it's the entire string as opposed to having all that extra dirty information in there, right? So what we can do now is see if we can denoise this this phrase or this set of sentences and see if we can see if it actually works. So let's go Macbeth is there, and then we're just going to pick Macbeth this time because it's now been limited to the first 200 characters. So you remember from our denoising, we had when and we that we added in there, and we do have when and we originally. So let's see if we denoise this accurately. When is gone. When shall three meet? We is gone as well. So this denoising actually did work, okay? The next thing I want to show you is sentiment analysis. So I'm going to show you these 3 lines of code next. First thing we do that was a little bit different is that we're not calling the same sentiment analysis object. We're calling this sentiment analysis object, which is the Vader sentiment intensity analyzer up here, okay? Vader is just another algorithm that does the same thing. In order for us to then calculate the sentiment of this, we call SID polarity scores, and we pass into a string. I'm going to show you this string called "This is awesome," and then we're going to print that dictionary, and you'll see what that looks like, okay? So let's just print that. You'll see that it says that it is not a negative phrase. It might be slightly neutral. It's definitely positive, and it's predicting this is compound positive, okay? Look at how some of this is subtle, though. Let's now just lowercase this and see if this influences the results. Remember these numbers. The numbers have changed, guys. So this sentiment analyzer notices or realizes that when you capitalize something, the intensity of the emotion should be a little bit stronger. We can go, "This sucks," and see how that works. Well, this definitely is a negative sounding phrase. It definitely was able to connect that. It thinks it might be slightly neutral, but it also agrees that a compound analysis is probably not positive. It also handles slang a little bit too, guys. So let's see here. It actually gives the same result because sucks and sucks with an X is basically the same. So this is a really powerful little sentiment analyzer that you can customize yourself. I do highly recommend that you go into the documentation for Vader and start playing around with it yourself because it can be very, very useful. The last thing I want to show you guys is this here. In fact, why don't we just remove that because we did all of this already. This next thing is creating n-grams. the first thing we're doing here is we're saying, hey, let's go into our Macbeth sentences and see if we can pair up words as much as we can. We basically just want bigrams because we're saying, go through this sentence and give us the pairs of 2. We can add 3s if we want. And so what it does is it creates an object, an n-grams object that we can then iterate across. Let's see what that looks like. So there you go. When the hurly, burly, you have all of these n-grams. Let's add 3 to this and create trigrams. There you have it. Trigrams definitely exist in this sentence. So with that in mind, guys, I think we should call it there. What did we learn today? We learned about denoising. We learned about sentiment analysis and n-gram analysis. We also learned how to access natural language toolkit corpus for basic testing. So the point of this class was really to just show you how easy some of these NLP techniques can be out of the box, but also how advanced there possibly could be as we get more into it, because we still have at least one more class where we can play with things a little bit. So I'm hoping you understand how powerful natural language processing in Python can start to be now that we're starting to get our feet wet with some of the very basic techniques around it. In our next class, we're going to try and integrate some statistical analysis into our NLP by conducting a TF-IDF estimate, which is basically like how unique sounding this document is. So with that, guys, thank you very much, and I'll see you next one.